Good afternoon, ladies and gentlemen. Today we're going to talk about the area of a regular polygon. We're going to give you that formula, and then we have a couple applications of using this formula. So as we discussed in class, the area of a regular polygon is 1/2 A times S times N, where N is the number of sides the polygon has. A is the apothem, which we know is the altitude of one of the separate isosceles triangles given within the polygon. We'll see that here in a bit. And S is the length of one side of the regular polygon. Here I have an example of a regular polygon with n sides, where n really isn't known. N could be 5, and could be 7, and could be 20, and could be 30, the number of sides. So the number of sides is just going to be undetermined, but it's going to be. But we're going to use the fact that if I have n sides, I want to look at the measure of one of those angles. And however many sides we have, we're going to have multiple isosceles triangles within that regular polygon. And what I need to know, because of the fact that every regular polygon can be inscribed in a circle, the measure of one of these central angles is always going to be 360 divided by n. We're going to use this fact later on in our examples. So let's go right to a couple examples. Let's review, say, hey, you know what? This is the formula, 1/2 ASN. This is the formula that we're going to use, and we're going to need to find these three variables each time. So example number 1, I want to find the area of a 5-sided regular polygon, and all that's given is the number of sides. The number of sides is given, so this is going to be our n, and the apothem is given, and so we know, we'll write that down, A is 10. What we need to do here is find the length of one side with the given information. Let's see if we can do that. The other thing I've done for this example, and I've not done this for my other example, is I've actually circumscribed a circle about that regular 5-sided polygon. So this 5-sided polygon is inscribed in this circle. We're going to use that here in a little bit. Here's the formula for the area of a regular polygon. 1/2 A times S times N. And right away we're going to plug in what we know. Well, we know that N is equal to 5. So I'm going to put 5 in for N. I also know they give me the apothem. A is equal to 10. I'm going to put that in, and I'm going to simplify that. 1/2 times 10 is 5. 5 times 5 is 25. So the area is 25S. What I need to find now is this S. And let's go to the next slide to see how I might find the length of one side with this given information. I have the same diagram here. What I need to know is that all of these central angles here are congruent. All of these angles are congruent, and we also know that the measure of a circle is 360 degrees. So all of these angles are going to sum to 360 degrees, and they're all the same. Therefore, the measure of one central angle is going to be 360 divided by 5. That tells me that each of these angles is 72 degrees. That's invaluable information. And that's information that I'm going to use to find the length of one side. And that's what my objective is, to find the length of one side. is to find this creature S. Well, what I'm going to do is I'm going to look at this particular right triangle right here, or this isosceles triangle. I'm going to look at this guy right here. And I know this central angle is 72, but it is isosceles, and we know that these are all congruent because these are all radii of the circumscribed circle. What I'm going to do, and then what I'm going to do is recall about the property of an isosceles right triangle, that this altitude, which we're going to call the apothem, is also an angle bisector. That tells me I'm going to pull this right triangle out here. I'm going to pull this rascal out here, and I'm going to pull it out and work with that particular triangle. And I know 36 is the measure of this angle because 36 is 1/2 of 72. They tell me that the apothem, or this length here, is 10, and we're going to use trigonometric ratios to find this B. What I need to note about B is that B is equal to 1/2 S. Why? That's true because this altitude in an isosceles right triangle is also a median. It's also a perpendicular bisector. So it's going to bisect that side there. And that side is S, so B is going to be 1/2 S. So let's use that information. This is what I have right here. What I'm going to do now is I'm going to find B using a trigonometric ratio. And what do I know? I know that the tangent of 36 degrees is the opposite over the adjacent. So the tangent of 36 degrees is B over 10. I want to solve for B. I'm going to multiply both sides by 10. The 10's cancel, and I have B is equal to 10 times tangent of 36. I'm going to round to 2 decimal places. I found this number with my calculator. I found tangent of 36. Multiply it by 10. That gives me 7.27. My final goal was to find S. S is 2 times B, so just multiply both sides by 2, and you get 14.54 is equal to S. And I'm going to take that, and I'm going to plug that back into this particular equation for the area that I had, 25S, this is S. So my area for that 5-sided regular polygon is 363.5 units squared. We really are not given what the units are for this example. Example number 2. Now I want to find the area of a regular polygon with 6 sides, where n is 6, where the radius is 7. It appears at first glance we don't have enough information, because what's the formula for the area of the regular polygon? The area of a regular polygon is 1/2 ANS, where A is the apothem, and S is the length of one side. And all I know this, I'm not given A, nor am I given S. All I'm given is the fact that n is equal to 6. So I'm going to go ahead and put 6 into this formula. So the area of this particular regular polygon, which is 6 sides, is going to be 1/2 A times S times 6, because it's 6-sided, and I know that 1/2 times 6 is 3. And so the area is going to be 3AS. So my objective now, let's see if we can find A and S with the given information. Hopefully you have noticed that I have not circumscribed a circle, but I do know that, do I not? That if I start anywhere and I go all the way around, all of those angles add up to 360, and all of these angles are congruent. So if I want the measure of one angle, I simply take 360 and divide it by the number of triangles. This case, 6. So 360 divided by 6 is going to be the measure of one of these angles. I think I have that on the next slide. And I do. So the measure of one central angle is 60 degrees. All of these rascals are 60 degrees. And same discussion I had with the previous example, I have an isosceles triangle. This apothem is an altitude. The altitude is also an angle bisector, which is also a perpendicular bisector. So right away, if each of these angles are 60, as they are, 360 divided by 6, these are all 60, that tells me that this angle right in here is 30 degrees. And I know that the radius, I was given that the radius was 7, so I'm going to pull this triangle out of the diagram. Place that bad boy right here. And I'm going to use the fact that, hey, this angle is 30. Oh, if that's 30 and this is 90, this has to be 60. And now I can look at the properties of a 30, 60, 90 triangle, which says the short leg is 1/2 of the hypotenuse. In this case, the hypotenuse was 7, so I know this measure is 7/2. And I also know from the properties of a 30, 60, 90 that the long leg is square root of 3 times the short leg. And that long leg in this case happens to be our desired apothem. Ooh, and what is our side length this time? What is this guy? This guy is going to be twice what we found to be 7/2. So S is going to be 2 times 7/2. What we found was B here. This is going to be B. And we know that S is 2 times this length. Therefore, 2 times 7/2 is 7. Now I have the apothem. 7/2 square root of 3. I have S has 7. And I'm just going to plug those into the formula. This is the last version of the formula that I had, was 3 times AS. And I'm going to put 7/2 square root of 3 in for A. I'm going to put 7 in for S. And if I want to simplify that with a calculator, you can. You can leave it like this. However you decide to do that. I hope that you've enjoyed these 2 examples. I hope that they help you with the particular assignment that we have. And I bid you good day.